I'm Ennemcien. Now let us see some objective type questions from electrostatics. First one. The total electric flux entering the cylindrical volume, which is placed in a uniform electric field of intensity capital E, such that the length of the cylinder is perpendicular to the field lines. Choices: A, E into pi dl by 2, pi into d into L by 2. Second choice, B, 0. C, pi E into, there is no pi, C is E into d into L. D, last choice, E into pi into d into L. See, the figure is given along with the problem. Uniform field. Intensity is E. This is a cylindrical volume. Diameter is D. Length is L. Now the total flux crossing the cylindrical volume will be 0, because total number of flux entering this side of the cylinder will be equal to total number leaving this side. So total flux, here it is minus, here it is plus, total number will be 0. Or you can use Gauss law. According to Gauss law, total flux crossing this closed volume, closed surface, is equal to 1 by epsilon 0 into charge enclosed by the surface. Here there is no charge inside the cylindrical volume, so that the total flux must be 0. Here the question is, what is the total flux entering the surface, cylindrical surface? That is the question. Now, just you consider 1/2 of this cylindrical volume. 1/2. Then this cross section will be a rectangle of breadth D, the diameter of cross section, and L, length of the cylinder. Here E is perpendicular to this cross section. So total flux, if E is constant, electric field is uniform, you can find the total flux by multiplying intensity and area of the surface, that is E into A. So here A is L into D, this is a rectangle, so area is length into breadth, L into D or D into L. That into E, that is the total flux entering. So flux psi E equals E into area. E into area. That is psi E equals E into dl. This is the answer. So the choice is C. I think it is C. Yes, it is C. Another question. What is the absolute electric potential at point distance A, small letter A, from a plane sheet of charge density sigma? Use the convention. Potential at infinity is 0. That is the question. I'm not giving you the choices, because you can use the formula as a piece of information for your use in exams. Say, this is the plane sheet of charge which is uniformly charged and charge density is sigma, charge per unit area. This is the point distant A from the plane sheet. You know that electric intensity E equals minus dV by dr, potential gradient. Therefore, dV equals a small potential difference, dV equals minus E into dr. Therefore, the absolute potential, which is the total potential at the point, which is equal to the total work done on 1 coulomb of charge to displace it from infinity, where V is 0, to this point. So you must integrate dV to get the total potential or absolute potential. So V equals integral E, since E is a constant, you can take it outside the integral. So minus E, intensity of plane sheet is sigma by 2 epsilon 0. That is a constant, or the field created by uniformly charged plane sheet is a constant, uniform field. So E is a constant, you can take it outside the integration. So minus E into integral infinity to A of dr. That is minus E into integral of dr is r within the limits infinity to A. Or that is minus A into, just you put the upper limit. In the place of r you put A, then you subtract the lower limit, minus. In the place of r you put infinity, so A minus infinity. You enter this minus into the brackets, so you get it as E infinity minus A. E into infinity is infinity, infinity minus EA is in another infinity, no, still infinity. So answer is infinity, or absolute potential at A or at any point near a charged plane sheet is always infinity. That is the answer. But the potential difference is another case. If you are asked to find the potential difference between 2 points R1 and R2 near the charge sheet, just use the formula dV equals E into dr, or E equals dV by dr. So just you avoid the minus sign. The magnitude is dV equals E into dr. Here dr is the distance between these 2 points, separation dr, that is R2 minus R1. So potential and E is sigma by 2 epsilon 0. So potential difference between these 2 points, dV equals sigma by 2 epsilon 0 into R2 minus R1. So there is a finite potential difference near a plane sheet, but absolute potential at every point will be infinity. So in competitive exams or multiple choice objective type questions, you need not use these steps, just you know the facts. That's all. Another question. Another question. This is a plane surface, yes, square surface of side L, small letter L. And a point charge is placed at this point, which is at a distance r from the surface. Here the question is, what is the total flux passing through the surface due to the charge Q? How will you find out it? In the question you are given, this R is less than L. Now the case is very simple. You construct a cubical surface with this as one side. So you get a spheric cubical surface like this. This is one of the 6 sides of this cube. and the charge q is inside. What is the total flux originating from this charge? Number of lines originating from 1 coulomb is 1 by epsilon 0. So total number of lines originating from charge q coulomb is 1 by epsilon 0 into q. So this number of lines q by epsilon 0 must cross through the 6 faces of this cube. So number of flux lines crossing one of the faces will be 1 by 6 of the total flux originated from q. So here the answer is q by 6 epsilon 0. That is the answer. Another question. These are two parallel plates charged with opposite electricity. This is bearing positive charge and this is bearing negative charge, equal in magnitude. So surface density of charge is sigma. A proton is projected horizontally into the space between the plates with velocity v0. The question is, what is the deflection of the proton as it leaves the space between the plates? That is the question. See, the electric field in between these two plates will be uniform. Let it be E, and that is directed from positive charged plate to the negatively charged plate. And the initial state of the proton is, it is moving in the horizontal direction with velocity v0. This, as it enters the field, this will experience an electrostatic force given by F equals E into Q, because E equals F by Q or F equals E into Q. Charge of proton is E plus E, small letter e. So F equals E into E. Therefore, acceleration of the electron is, use Newton's law, F equals ma, so A equals F by m. That is E by m. Time for passing, this acceleration is vertically down in the direction of the electric field. So there is only one force on the proton, that is vertically down. There is no force in the horizontal direction, so that horizontal velocity v0 will remain constant throughout the motion. This is just like a parabola projected horizontally in the gravitational field of Earth. It will assume a parabolic path. So, time of passage, time taken by the proton to cross this space. V0 is constant, distance is L, so T equals L by V0. T equals L by V0. Now you consider the vertical motion. At the beginning, vertical velocity is 0. So you take U as 0. T equals L by V0. Acceleration, vertical acceleration is E by m. So what is the vertical displacement? Let it be y. This is the unknown y, vertical displacement as it leaves the space between the plates. So S equals y. You use the equation S equals ut plus half at square. U being 0, S equals half at square. So S equals half at square, S is y. Y equals half into E by m into T square L square by V0 square. Or the answer is L square by 2mv0 square. This is the vertic deflection as the proton leaves the electric field. Thank you.